Welcome to the next lecture, my dear friends. In the previous lecture, we have completed the trickling filter topic. So we are entering into the new topic, that is sludge digestion tank. Sludge digestion tank. See, so far we have seen the treatment of the sewage in primary sedimentation tank, the treatment of sewage in secondary stage, that is either it may be activated sludge process, or it may be trickling filter, or it may be RBC, or it may be any network, any system. So after this treatment, we are sending that effluent into the secondary sedimentation tank. From there, we are collecting the effluent. So if you look at the primary sedimentation tank, so far whatever we have discussed is everywhere. This is a first degree treatment, and we are sending it into the second degree treatment, whatever the second degree treatment. Okay, anything. So it may be ASP, it may be trickling filter, or it may be anything. So this is second degree treatment. Now we are sending again the effluent into the secondary sedimentation tank. Now in the primary sedimentation tank, we are getting some amount. I have told you already, we are removing some BOD in the primary sedimentation tank. That is 30% of the BOD we are removing here. So that is removed in the form of sludge. Okay. So whatever the settled part, so that is nothing but sludge. So we are removing some part of sludge here. Similarly, here also some part of sludge will form. So after the treatment of the carbonaceous matter, so whatever the nitrified matter is present, that nitrified matter, sludge will be formed here. So this sludge and this sludge, so which is coming out of these two, will be taken into the sludge digestion tank. Okay, so whatever the sludge that is being developed out of the system, that sludge will be treated. Whatever be the sludge, wherever it forms, that sludge will be treated in the sludge digestion tank. Generally, if you look at the primary sedimentation tank, the primary sedimentation tank will have a moisture content. So in that sludge, whatever the sludge that is being generated, so in that sludge 95% is moisture, that is water. So 95% is water and 5% is only the organic matter. Organic matter, solids, not only organic, inorganic matter will also present, so we call this as solids. So 95% is water, 5% is solid when it is from primary sedimentation tank, because the quantity of the organic matter is more. Whereas if you are deriving this from the secondary sedimentation tank, 96 to 98% will be water, so 2 to 4% will be solids. So that means here we need to treat the solid. If we treat the solid, this water can be dried on the drying beds. Okay, so that means here the sludge digestion. So this solids are associated with this much of water. So here we are having two tasks to do here. One is reducing the volume of this sludge. How can we reduce? Because we need to treat only solids. So along with the solids, this much of water is coming into the system. To reduce the volume of the system, okay, we need to reduce the volume of the sewage. How can we reduce the volume of the sewage? Generally, we use sludge thickeners. We call them as sludge thickeners. So these sludge thickener will reduce the volume of the sludge. It will thicken. It will increase the density of the sludge, by which the volume of the sludge will reduces. So that the system, the sludge digestion tank or sludge digester volume can be reduced. It will reduce the cost, as well as more sewage you can treat with less time if you reduce the volume of the sewage or volume of the sludge. Okay. So first task I want to do is reduce the volume. How can we reduce the volume? We cannot reduce the solid concentration. because solids we need to treat them, but we can reduce the moisture. So this much of moisture is not needed, we can reduce the moisture. So here sludge thickening or volumetric reduction of the sludge can be achieved by reducing the moisture of the sludge in the sludge thickener. Okay, so next task is reducing the strength. So strength reduction takes place in the sludge digester itself. So sludge digester will take care of the sludge. Again here there are two things that can happen. If you look at the sludge from the primary sedimentation tank, from the primary sedimentation tank, the sludge will contain more amount of organic matter. So here the sludge, whatever you are deriving, it will be having more organic matter and less biomass. That is, microorganism will be, so organic matter will be more and biomass is less in case of primary sedimentation tank, because we are removing it before the treatment has started. So in primary sedimentation tank we are not allowing the decomposition to take place. We only, whatever the sludge that is coming, so we are taking out of the sedimentation tank, we are bringing that sludge to the sludge digestion tank. So there organic matter will be more, biomass will be less. But whereas whatever the sludge you are deriving from the secondary sedimentation tank, in the secondary sedimentation tank already the organic matter is completely exhausted. The carbonaceous matter is gone. So only nitrified demand is present. So organic matter will be less, but the biomass concentration is very high. The biomass concentration will be very high. So generally the sludge digestion can be done in aerobic method also. But if you do it in aerobic method, I told you, if you are doing for this sludge, if you are doing in aerobic method, that is not a problem, because here as the biomass is more, if though you do in aerobic method, endogenous respiration will occur because less amount of organic matter is present, more biomass is present. So if you leave this under aerobic sludge digestion also, it will not cause any trouble, it will end up in endogenous phase. But here the organic matter is very high, biomass is very less, so the biomass growth will increases. So if you do this in aerobic, then what happens? We cannot control the biomass growth. So that is why generally, so this kind of sludge where the organic matter is more and biomass is less, those kind of sludge we need to treat in the anaerobic state. So that means, so overall, so as this is the major organic matter content which we are having, because this organic matter is already majority is consumed. So looking at the organic matter point of view, we generally take all of them under anaerobic state only, because here if you mix these two, organic matter will be more and biomass also will be more, so that what happens, the equilibrium state we can achieve. But here, as this is anaerobic method, so this method is it cannot be directly taking place. So as I told you, aerobic digestion takes place immediately, but anaerobic digestion takes place in a stage. So what are the two stages that will be present? One is acid formation stage and another one is methane forming stage. So as we are doing this sludge digestion, it is a suspended growth anaerobic unit. So that is why here it is an anaerobic unit, so it takes place, the sludge digestion will take place in two stages. One is acid formers So in this stage, I already told you, so acid forming bacteria will convert all the organic matter. So the complex organic matter is converted into simple light molecular weighted So it will convert the whatever the complex organic matter, it will convert this into light weighted acids and alcohols. That is the work of acid forming bacteria. Actually these acid formers are facultative. These are facultative bacteria. So these are the facultative bacteria. So that is why they can work in aerobic state as well as anaerobic state. Okay, they can work in aerobic state and anaerobic state. So the methane forming bacteria is a pure anaerobic bacteria. So this acid forming bacteria, they can survive anywhere. Okay, so they are strong bacteria, but the methane forming bacteria are very sensitive. Okay, they can work within the specified pH range only. If the pH range is also not maintained, they will die. Okay, so sometimes what we call this shock loading. What is meant by the shock loading is, so when you are doing combined system, when we are running a combined system of sewerage, then what happens during rains? Suddenly rainwater will also come along with the sewage. Okay, so even though you control it or not control it, always the rainwater will enter into the sewage. Whether you design it a separate system also, it is not necessarily possible all the rainwater to go into the storm drainage only. If the rainwater is very excess, then it may enter into the sewage also. So sewage, now the rainwater is not anticipated, okay, into this loading sludge digestion tank. So if those kind of shock loadings, when the rainwater, because of rainwater, suddenly what happens, the sewage concentration will, organic matter concentration will fall down completely, and the pH, so here the pH it will maintain. So the acid methane formers will work within a specified pH. When that pH changes, then then what happens? That methane forming bacteria will die and the methane formation will ceases. So that is why the methane forming bacteria, this should be taken care during the decomposition. Okay, after this acid formers, so methane formers will come into the picture. So in this stage what happens? All the organic matter, whatever the organic matter is present, the organic matter is converted, the acids and alcohols are converted into the methane gas. Okay, so and here why we are focusing on methane gas is, methane gas is having the calorific value, so which can be used as a fuel. It is combustible. Okay, that is the importance of the methane gas. So this is how generally sludge digestion tank will work. So now the important points here is sludge digestion process. During the sludge digestion process, we are doing two things. One is we need to reduce the volume and we need to reduce the strength of the organic matter, that is BOD reduction. Okay, so now how generally we do the BOD reduction, how generally we do the volumetric reduction. So let us see first volumetric reduction and then we will understand the strength reduction. Okay. So generally we use the sludge thickener to reduce the volume of the sludge. Reduce the volume of the sludge. And here, so if you look at the mass volume relationship of the sludge, if you look at the mass and volume, so mass volume relation of the sludge, if you look at this, so the density of the sludge, if rho of sludge is taken as like this, the rho of sludge is equal to mass of the sludge by volume of the sludge. So rho of the sludge is equal to mass of sludge by volume of sludge. So again this sludge specific gravity, if you want the sludge specific gravity, this is rho of sludge. If you want sludge specific gravity, then rho of sludge by rho of water. And this rho of sludge is a combination of water and the solids. Okay, so it is containing different kinds of materials in it. Now for example, so it is containing, the sludge is containing different kinds of molecules. Let us say that is A, and some molecule B, some molecule C, like that. So different molecules are there. Okay, so different proportions are also there. So A, proportion of A is P1. Okay, proportion of B is P2, proportion of C is P3. So likewise these are the proportions. Okay, or like we can say the proportion of A is like let us take it as percentage. Proportion of A is, take it as proportion of A is percentage A. So here let us take the proportion of A as percentage A, proportion of B as percentage B. Okay. Similarly, proportion of C is percentage C. Okay, so the density of the sludge is nothing but it is dependent on the density of the sludges. Okay, so sludge means it is a combination of different material. Okay, the organic matter may be coming from any material. So that is why the sludge density of the sludge is dependent on the what are all the different materials that is coming into the sludge and forming a sludge. And also the most important material which decides the sludge density is water, because sludge contains almost 95 to 98% of the water. That is why, so the rho of the sludge is near about 1000 only, but it is little more than 1000 because of the presence of other organic matter along with the water. Okay, so likewise these are the proportions. Now if I want the density of the sludge if I want the density of the sludge or specific gravity of the sludge, so 100 by rho of sludge, 100 by rho of sludge is equal to, okay, percentage A by rho of A, percentage B by rho of B, plus percentage C by rho of C, and so on. See, either we can write this formula like this, or we can write the formula in terms of specific gravity also. We can write the formula in terms of specific gravity. If you want the specific gravity of the sludge is equal to percentage A and the what is the specific gravity of A, percentage B and what is the specific gravity of B, and percentage C and what is the specific gravity of C. So likewise we can write the equation. So if you know the specific gravities or densities of the molecules, densities of the molecules present inside this sludge, okay, we can find the density of the sludge. Majorly we take the major components of the sludge, we take them as one is water, another thing is solids, another thing is solids. So we, by using the specific gravity or densities of water and the density of the solid, we can find the density of the sludge. Okay. So the same formula, remember, the same formula we will use in solid waste management also. There also we will recall this formula. Instead of rho of sludge there we take the density of the solid waste. Okay, because solid waste is also a combination of different wastes. So there also we will recall this formula. Remember this formula. For now, we will apply this formula to our sludge. Okay. So here for sludge, if you assume that only it is having the solids and water. Okay. So now solids and water. So 100 by specific gravity of the sludge is equal to percentage solids by specific gravity of solids plus percentage of water or moisture by specific gravity of water. And again solids, if you see, there will be volatile solids and there will be non-volatile solids. See, solids, if you look at the solids in the sludge, okay, if you look at the solids in the sludge, solids are of two types. One is volatile and non-volatile, or fixed. Non-volatile. So this is fixed solid. Fixed solids are called inorganic solids. Fixed solids, these are called inorganic, like silt, clay, these kind of inorganic solids. So they will remain same even after the digestion is completed. Okay, inorganic solids. If you take organic solids, so these organic solids will change its nature. So though they are solids in the before digestion takes place, but after the completion of the digestion, this organic matter are called volatile solids. They will change its form, they will evaporate, they will go out of the system in the form of a gas. Okay, so those are called volatile solids. Now here, if you want the solids, here this is solids. So now 100 by specific gravity of solid, if solid's specific gravity is not given, but the specific gravity of volatile solids and specific gravity of non-volatile is given, then the specific gravity of the solids we need to find from this formula. So percentage of non-volatile by specific gravity of non-volatile, specific gravity of non-volatile plus percentage of volatile by specific gravity of volatile solids, specific gravity of volatile solids. So by this way we can find the specific gravity of the solids. So once you know the specific gravity of the solids, we can find the specific gravity of the sludge. Once you know the specific gravity of the sludge, we can find the moisture content and what is the volume to which we need to reduce. All those things we will understand only if you know the specific gravity and the density. In the same manner, we can find the density of the sludge also. Rho of sludge is equal to percentage solids by rho of solids plus percentage water by rho of water. So these are the very useful formulas for us in the GATE examination. So they will definitely ask us to find the density of the sludge by giving us the density of the solids and the water content, simply water content. So now so let us see the volume reduction of the sludge, how we do. So here I am taking the moisture content of the pre-treated sludge. Okay, so before sending the sludge into sludge thickener, I will assume the moisture content as P1. and I will assume the volume of the sludge before the treatment or before thickening, that is V1, and after thickening what I will assume is the density. I will assume the moisture content is P2 and the volume of the sludge after sludge thickening I take it as V2. Okay, so let us now start our analysis. So let P1 is the initial moisture content. Let P1 is the initial moisture content. So this is before thickening of the sludge, and V1 is the initial volume, and V1 is the initial volume. Initial volume of the sludge. Okay. So if the percentage moisture content of the sludge, okay, so now after sludge thickening, so the percentage moisture has been reduced to P2. Okay, P2 is the reduced moisture content after sludge thickening. And V2 is the volume. V2 is the volume of a thickened sludge. V2 is the volume of the thickened sludge. Okay, so the concentration of the solids inside the sludge is equal to, okay, concentration of the solids in the sludge is equal to whatever the concentration. Here, when we are sending some solids concentration into the sludge thickener, okay, so when we are sending some concentration of the solids in the sludge thickener, and the sludge thickener will not reduce the concentration of the solids, but it will reduce the moisture content. But when we are sending some concentration of the solids into the sludge digester, okay, so sludge thickener role is to reduce the volume of the sludge, whereas sludge digester role is to reduce the concentration of the solids inside the sludge. So here, when we are sending this some concentration of solids into the sludge digester, okay, and some amount of solids concentration is removed inside the digester, okay, some amount of concentration of the solids will be removed inside the digester. So whatever the concentration is removed, that will convert into the volatile form. I told you already. So the volatile, whatever the organic matter present inside the organic matter will act like a volatile solid. So these volatile solids will get removed inside the digester. But if any volatile solids are not removed, then that will be sent out of in the effluent of the sludge digestion tank. So now concentration of solids, if you are sending into the system, let Ci is the concentration of solids sent into the system, into the digester. Okay, so let efficiency, eta is the efficiency of solids removal, in the digester. Now what is the amount of solids that will come out for drying. Okay, so for drying purpose, how much concentration of the solids that will come out? Concentration of solids in the effluent of the digester. In the effluent of the digester. In the effluent of digester is concentration of the solids which we are sending into the system. In that, what is the efficiency of removal? Into the what is the efficiency of the removal? That much concentration is removed. Okay, so this much concentration is removed. So here, so this is the concentration of the solids you are applying into the digester. This is the efficiency of the solids that are removed in the digester, and in this is removed part. And what is the amount of solids that will present in the effluent? That will be equal to, so 1 minus this. That means how much how much solids you are sending into the digester, and what is the efficiency of the removal of the solids of the digester, and the rest will come out of the digester in the form of a solid sludge, which we need to apply on the land irrigation. I will tell you what we will do after this sludge digestion. After the sludge digestion, there will be digested sludge. That digested sludge will also contain some amount of solids. Okay, that digested sludge will also contain some amount of solids. So the amount of concentration of the solid in the digested sludge. So this is the amount of the solids in the digested sludge. Okay, so now what we need to do with the digested sludge, we will discuss in the next topic, that is solid waste management. So likewise, these are the solids which will come out of the system when we give solids to the system, and system will destruct some solids, and it will give some solids out of the system. So how much solids are coming out of the system? Okay, so that will be calculated using this formula. Now here, total mass of dry solids in the sludge. Okay, total mass of dry solids. Here, this is the concentration of the solids in the effluent. So what is the total mass of dry solids? Total mass of dry solids. Total mass of dry solids in the sludge. So mass means, so when you know the how much wastewater or how much sludge is entering into the sludge digester, let Q is the sludge which is entering into the sludge digester. So this is in liter per day. So what is the concentration of the solid in it? What is the concentration of the solid in it? So this is the concentration, total mass of the dry solids inside the sludge. So this is the concentration of the dry solid. This is the total amount of water that is coming into the system. So total mass of the dry solids in sludge. Okay, in sludge, let us take it as M. Let us take it as M. M is equal to Q into C. Okay, Q into C. That M value will be taken as in kg per day. We will take this as in kg per day. So this is the mass of the dry solids, or simply mass of the solids inside the sludge. Mass of the solids inside the sludge. So here, if P1 is the moisture, okay, if P1 is the moisture inside the sludge, then what is the proportion of the solids? So 100 minus P1. So 100 minus, if you are taking 100 kg of sludge, if you are taking 100 kg of sludge, so 100 minus P1 kg of dry solids. Okay, 100 minus P1 kg of dry solid. 100 minus P1 kg of dry solid sludge. 100 minus P1 kg of dry solid sludge produces 100 kg of wet sludge. 100 kg of 100 kg of wet sludge. Okay, so 100 minus P1 kg of wet sludge or dry solid sludge will produce 100 kg of wet sludge. So 100 minus P1 kg of dry solid sludge is producing a wet sludge of 100 kg. Okay, so that means if we are taking P1 is the initial moisture content. Okay, so P1 is the initial moisture content means if you are taking 100 kg of wet sludge, 100 kg of wet sludge if you are taking, in that the wetness, that is moisture, is P1 and the solids content, that is dry sludge, that is 100 minus P1. So 100 minus P1 kg of dry solid sludge will produce a 100 kg of wet sludge. So 1 kg dry solids, 1 kg of dry solid sludge produce 100 by 100 minus P1 kg of wet sludge. Okay, so 1 kg is producing this much. So m kg per day, m kg per day of dry solid sludge produce 100 by into m kg per day of wet sludge. It will produce 100 by 100 minus P1 into m kg per day of wet sludge. So mass of the sludge produced, so the mass of sludge produced at P1 moisture content is equal to, at P1 moisture content is equal to, mass of sludge produced at P1 moisture content is equal to 100 by this one, 100 by 100 minus P1 into m kg per day, where m is the mass of the solids, mass of the dry solids that are produced per day. Okay, so now here one more point I would like to add is, see the solids, whatever the solids, they are coming from where? They are coming from the sludge. Sludge coming from where? Sludge is coming from either from primary sedimentation tank or from secondary sedimentation tank. Okay, so here sometimes in the examination, okay, sometimes in the examination they will ask like this. Very important to understand this. See here, first of all, so this is the system starting. So from the screening grid chamber and the skimming tank, the influent is entering into where? The primary sedimentation tank. Okay, so this primary sedimentation tank will have some efficiency of removal. Let efficiency is eta. Okay, let efficiency is eta. So here the solids concentration, okay, so let the solids concentration is Ci. At this point I take the solids concentration is Ci, and now so this is the effluent of the primary sedimentation tank. So from here some solids will come to the sludge digestion. From here some solids will come in sludge to the sludge digestion tank. How much solids will come here? So if this is the solids entered into the primary sedimentation tank and this is the solids removed in the primary sedimentation tank, then how many solids are coming from this location? So eta into Ci. So this is the amount of solids which are entering into sludge digestion tank. Similarly, we are doing the secondary treatment. This is primary treatment. Similarly, there will be secondary treatment also. So from the secondary sedimentation tank also, so there will be some efficiency. Let we take this as eta 1 here. So there is another concentration will enter. Okay, so let us see, this is another concentration. So or else I will put it as C1. Let the concentration of the solids here is C2, which is entering into the secondary sedimentation tank, and the secondary sedimentation tank is also removing some amount of organic, some amount of sludge here, solids here. So let that is eta 2. So here what are the solids from here they are entering, that is eta 2 into C2. So these solids will enter into sludge digestion tank. These solids will enter into sludge digestion tank. Here the sludge digestion tank will take these solids. So what are the solids entering into sludge digestion tank? What are the solids entering into sludge digestion tank? The solids entering into sludge digestion tank is eta 1 C1 plus eta 2 C2, where C1 is the concentration of sludge, concentration of solids, or we can say concentration of dry solids in influent of PST. C2 is concentration of dry solids in influent of SST, and efficiency eta 1 is efficiency of solid removal, solids removal. So eta 1 is efficiency of removal of solids in primary sedimentation tank. Similarly, eta 2 is efficiency of removal of solids in secondary sedimentation tank. Now here, whatever the solids entering into sludge digestion tank, here from the sludge digestion tank also, after the sludge digestion, digested sludge is produced. Here if you see the efficiency of the removal of the sludge, means here sludge is not removed, actually sludge is digested, so destructed. So for example, if this much of solids are entering, this much of solid is entering, and for some solid is destructed in it, for example efficiency, so this is the quantity of the solid entering. And eta 3, efficiency of solids destruction, so that means in the whatever the solids that are entering into the sludge digestion, so this much of efficiency, this much of percentage of solids are getting destructed. So how many solids now from the sludge digestion tank? So this is a destructed part. Okay, this is the destructed part. So from this total solids, this much of solids are got destructed. Now how many solids are entering out of the system? So total entering into the system minus total solids got destructed. That is the amount of digested solids or digested sludge which will go out of the system for land irrigation. Okay, so for further processes. So that is what I have told you. So likewise, sometimes they won't give you directly how many solids are entering into sludge digestion tank. They will tell you how many solids are being removed in the primary sedimentation tank, how many solids are being removed in the secondary sedimentation tank. So or else combinedly they will give these many solids are removed in the first and primary and secondary treatment, and how many from there you need to calculate what is the total amounts of concentration of the solids that are entering into the sludge digestion tank. Sometimes they won't directly give you M value, they will give you the M value indirectly, you need to calculate it. Okay. So now now I will conclude the session here. We will continue this volumetric reduction, how to do this. Okay, we will continue this concept in the next session. Thank you so much.